Hello, this is topic 8-8 on linear translations. So we've been talking about quadratic translations in 8-5, 6, and 7. Now we're going to see that those same rules apply when we're translating linearly. So first some examples. How would this change for the following? Here, that's going to move it up 5, down 4, right 2, and left 3. All very simple. Well, let's see what happens when we have these linear equations. Well, plus 5, this is outside of parentheses, so it's going to move it up 5. Minus 5, it's going to move it down 5. Here, this is going to move it right 5. And here, this would move it left 5. We follow the same rules that we followed up here with the quadratics as with the linears. If it's outside the parentheses, it moves it up or down. If it's inside parentheses, it moves it left or right. So let's see what we can do here. We're given this initial equation, and we want to know what happens. So we're starting off at y equals 3x minus 1. We want to move down 2, so that means we need to subtract 2. So y equals 3x minus 3. Now if we want to move up 1, we're starting with y equals 3x minus 1. And we want to add 1. Gives us y equals 3x plus 0, which is just y equals 3x. So, now if this were just 3x, moving down 2 would be 3x minus 2, and up 1 would be 3x plus 1. But this wasn't just y equals 3x. This was already 3x minus 1, which means it's starting at minus 1, at down 1. So if we go down 2, we're now down a total of 3. We started at down 1, we go up 1, we're now at equilibrium plus 0. Let's go ahead and see how this works with problems 11 and 12. Now remember, we're starting with y equals 3x minus 1. We want to move left 2, y equals 3x plus 2 minus 1. Which, let's go ahead and distribute. Y equals 3x plus 6 minus 1, which makes y equals 3x plus 5. We're moving right 4. We start with y equals 3x minus 4 minus 1. Because it was 3x minus 1. So we distribute. Y equals 3x minus 12 minus 1. So y equals 3x minus 13. Quite simple. Well, let's go ahead and look at these other examples. We're starting with this equation. Well, I'm going to go ahead and turn this equation into something that's easy to use. I'm going to add y and add 4 to both sides. So that's going to give me that 3x plus 4 equals y. Or y equals 3x plus 4. This will put it into y equals mx plus b format, which is very helpful to us. So, which line is parallel? Parallel means that this has the same slope. So the slope of a line that's parallel is going to have the same m value. The slope would be 3. Now, if we go perpendicular, we're looking at a negative reciprocal. So 3 over 1 turns into 1 over 3 negative. Now what happens if we move it up 2? Well, y equals 3x plus 4 plus 2, which means that y equals 3x plus 6. If we move it down 5, y equals 3x plus 4 minus 5, which turns into y equals 3x minus 1. If we move it right 4, y equals 3, x plus minus 4. Remember, it's backwards from how we think. Plus 4. So we need to distribute. So y equals 3x minus 12 plus 4, which is y equals 3x minus 8. And if we move it left 6, y equals 3x plus 6 plus 4. Remember, it's backwards from how we think for right and left. So y equals 3x plus 18 plus 4 when we distribute that 3. Combine like terms, y equals 3x plus 22. So, all very simple. Remember the same rules that you've been using for the last 3 lessons. Use them today in today's lesson. We're just going to apply it to linear equations instead of quadratics. Good luck on your assignment. Have a good day.